It started as a simple grass, yet it's anything but simple. For something so small, it packs a wallop, morphs into raw materials, and even protects us. And science has just scratched the surface of its vast potential.
We don't know everything there is to know about wheat. We're always innovating, always finding new properties and new applications.
Wheat, coming up right now on How Stuff Works. When we think of wheat, we think of bread. But this simple grain is everywhere. It's in familiar foods, hiding in fillers, and faking out our taste buds in places we would never suspect. If you're eating, you're probably eating wheat. Wheat is as old as agriculture itself, taking advantage of cutting-edge technologies to stake its claim as a plastic, a wood, and a futuristic indoor crop that may just rescue us from starvation. Without wheat, you'd have to put down that pasta, pour that beer down the drain, deep six that crab cake, and step away from that golf tee. If there was no wheat, you'd have to, because it's not just for bread anymore. This may look like a typical door, but under its skin, it's a lot more. Not just because it's fire resistant up to 1700 degrees, or that it is exceptionally strong, or even that it's made with green technology. This door is made of wheat. Yep, wheat. The same stuff that's in cookies and crackers.
Doors are very important. They're barriers, and they do protect us. There are 3 parts to a door, and the part that is the wheat is actually the core, which is about 90% of the door itself.
But how can wheat make a door? Isn't that a job for wood? After all, wheat is just a grass. True, but it's a lot different than your front lawn. In the genus Triticum, grass is a common green plant with jointed stems and long, narrow leaves. And it's these jointed stems that provide the strength to stop a raging blaze.
We're going to go ahead and cut out a block to see what's inside. This door is a 60-minute fire-rated door. A comparable wood door would be 20% heavier, and yet it wouldn't hold the 60-minute rating. As you can see here, we have the 3 parts of the door, which is the core, the plug, and the veneer. Core being the most important part for the fire rating.
And that's just one reason why wheat is in more places than you might think. Mainly known as a food source, wheat is one of the top 3 produced crops in the world. Wheat, after all, is the main ingredient in breads, pasta, and even the beloved pizza. It may look delicate, but this is one tough plant.
I think wheat's also unique in that it's grown in such diverse places. So it's grown at sea level, it's grown at high elevations, it's grown in the tropics, it's grown at high latitudes, it's grown under high rainfall conditions, it's grown under drought conditions. So it's a very adaptable crop.
From the Australian outback to the northern chill of Russia, and from the badlands of the Dakotas to the Argentinian coast, wheat is there. Within the 6 scientific classes of wheat are more than 30,000 different varieties. What makes them so different? Each variety is defined by specific physical characteristics, adaptability, and grain yield. But what they do share is a kernel and the goods inside. There are 3 major parts of a kernel of wheat. The outer coating, called bran, is where the fiber is. The heart of the kernel, or germ, contains essential oils, vitamins, and minerals. But most of the kernel is made up of something called the endosperm, where the complex carbohydrates are stored, and 2 proteins that work together to make gluten. But what is gluten? It's a protein with elastic qualities that makes wheat unique and makes bread stretchy enough to rise.
The gluten that gives structure to bread and cookies and other products that we make from wheat. And that's pretty unique to wheat in terms of those protein properties.
Durum wheat is the most ancient wheat and has the greatest concentration of gluten, which makes it very tough. Flexibility and strength make durum wheat ideal for pasta products. Hard red spring wheat contains slightly less gluten, which makes it great in breads because it withstands expansion and is light enough to rise. If you need to bake a cake or a pastry, soft red winter or soft white wheat would be best. They have even less gluten, which makes for softer dough. Hard white wheat. This wheat is only grown in 10 states, but contains almost 12% protein, making it very nutritious. Hard red winter wheat is king. It is the largest wheat crop in the United States, with more than 40 million acres harvested annually, and its gluten content makes it the most versatile. These grains pack a punch filled with protein, vitamins, and minerals. But how do these little berries get to our table? It starts in the wheat field, and if Mother Nature doesn't cooperate, it'll end there too. Kansas may be the largest wheat producer in the United States, but each year, fingers are crossed and prayers are recited as harvest approaches.
Oh yeah, won't be today.
Why? Because the breadbasket of America grows hard red winter wheat. It is planted in the fall before the weather turns. The seeds go dormant during the winter chill, then sprout in the spring. But the Midwest in the spring can be a very unpredictable place. Spring downpours could mean floods. Devastating hailstorms threaten to flatten entire fields of wheat. And let's not forget the destruction a tornado can cause. So when does the wheat grower make his decision to harvest? His livelihood relies on the harvest. Within a matter of 2 weeks, wheat will change from moist and green to dry and golden, but it will spoil in the field just as fast. The wheat is ready to harvest, but it has rained heavily over the past 2 nights. And even for a 4th-generation wheat grower like Greg Johansson, nerves are on edge.
The stem should snap off in your hand when you break it off the head, but as of today, that ain't gonna happen. Being wet doesn't thresh out in your hand very well. And you should be able to bite them and they'll snap. I mean, they'll be hard. And these, I can put my finger in them. That's showed that they've taken quite a bit of moisture. It's back to life around here. You know, that's just the way it is.
The Johansson's 800 acres of wheat should be cut in 1 week. But the soil is muddy and the wheat lies flat in spots. What can he do? The only thing he can: wait for the earth to dry and pray for no more rain.
Grain-wise, I think if the sun would come out and we get a breeze like this, probably by Sunday, in a couple days. But I'm not sure that is feasible being that wet on the ground. 1.5 inches of rain, and this being covered like this, the sun can't get to it.
Luckily, Mother Nature has cooperated with a break in the rain for a few days. But the skies remain ominous. Now, time is as precious as the crop itself. A full-court press is underway to get the fields of wheat harvested before the next onslaught of weather.
Ooh-wee.
But how do you actually get the wheat out of the wheat field? Well, the best way is to use wheat's most valuable ally. 80 tons and 2 stories tall, the wheat harvester uses a grain header attachment with a razor-sharp scythe that cuts the stalks, threshes the grain out, and discards the chaff and straw, all in one pass.
Slow going, it's down pretty bad. Down here in the trees and it's kind of damp, the straw is, so you gotta kind of slow, you'll plug it up. But it's rolling all right, it's just gotta be some slow going.
Since harvest days are very long and can drag on into the wee hours of the night, one of the benefits of a family farm is everyone chips in to get the job done.
Yeah, it's kind of fun to have everybody out helping. Having family help, you know they're gonna do it right and you don't have to worry about it.
So once the kernels are harvested, where do they go? They are transferred to a stake bed truck, where the wheat begins its journey off the farm. From seed to harvest, wheat growers endure months of harsh weather in the hopes of growing a successful and nourishing crop. But during harvest, where does all the grain go? To the nearest grain elevator as soon as possible.
Well, we're about to get this truck full. Should be able to dump here in another 15, 20 minutes and get another small dump from the combine. And
With what we got left, I suppose there's probably 2 more of these loads and maybe 2 more of the bigger truckloads yet before we get done.
1 acre of Greg's wheat will feed over 9,000 people for an entire day. But that's a drop in the bucket when it comes to the amount of grain stored in just one average-sized grain elevator, which could hold up to 7 million bushels. Wheat can actually stay in great condition for years if stored at the proper temperature with little humidity. But if proper storage doesn't happen, the grain could get too moist and kernels will go bad, or too dry and they will shrivel up. Or, if conditions are right, they could explode. That's right, explode. Believe it or not, there is a tiny part of the wheat kernel that is deadly. It's the wheat dust particle, something smaller than the diameter of a human hair. Just like flaky dry skin, tiny dust fragments fly off the outer bran during transport.
The requirement of a dust explosion is to have small particles dispersed in a cloud so that they're well surrounded by the oxygen of air. The size of those particles are critical. The maximum is about 300 microns, but typically you want about 30 microns. It's even smaller than you might think of as a grain of sugar.
And from there, it doesn't take much, a welding spark or even static discharge, to turn a grain silo into a 120-foot bomb. To prove it, chemical expert and Professor Jimmy Oxley shows the explosive nature of dust with a few simple tools.
We're going to attempt a laboratory demonstration of a dust explosion with household flour, a candle for the ignition source, and a 1-gallon paint pan for confinement. And here we go. If you compare a dust explosion to a detonation of high explosives, the dust explosion is quite minor. Now, to human beings that are in the unfortunate way, it's going to be catastrophic.
The recipe for a wheat bomb is simple: tiny particles, confinement, and an ignition source. To prevent catastrophe, grain elevators run safety protocols, including ventilation systems, constant maintenance, and, not surprisingly, absolutely no open flames. So, under a watchful eye, wheat continues its trek to the next step in its long journey: the mill. This step, however, is gonna hurt a little. Each compact kernel is packed with vitamins and minerals, including iron, thiamine, and potassium, as well as vital carbohydrates, fiber, and protein. But how do you get them out of the kernel? That's where the mill comes in. At the mill, each kernel is smashed and transformed into flour.
Flour milling is both a science and an art. There is a science to it in the flow diagrams and how it's laid out in the process. There's also an art to it that the flour miller has to know how to adjust the grind by feel and touch and look.
Mills produce white flour or whole wheat flour, and the difference between the two is all on the inside, in the kernel. White flour contains only the endosperm, while whole wheat flour includes every single part of the kernel: bran, endosperm, and germ. So, for every bushel of wheat, 42 loaves of white bread are produced, as compared to 60 loaves of whole wheat bread. And that's a lot of bread, no matter how you slice it. At this Horizon Mill outside of Los Angeles, California, train cars unload their 200,000-pound payloads of wheat kernels from the Midwest. This steady stream of wheat will be transformed into 2 million pounds of flour every 24 hours. But how does the mill get so much flour from such tiny sources? The answer lies within a complex maze of chutes, tubes, pneumatic pressure systems, purifiers, and sifters that converts the wheat kernels to flour. Perhaps the most critical step is what the industry refers to as the first break. Like smashing a coconut to get the milk inside. This modern version of an ancient grinding stone gets the job done in the blink of an eye.
It first goes to the first break rolls, and they're a corrugated roll, and they're 10 to 12 corrugations per inch. And they're spiraled a little bit, somewhere around 3/4 of an inch. And the rolls come against each other, only they go at different speed. One's going 2.5 times the speed of the other one. So you're not really grinding, you're shearing. It's a shearing action.
Referred to as middlings after the first break, the endosperm is still quite coarse. To reach a finer flour consistency, the endosperm undergoes 5 more rounds of grinding and sifting.
So it's a continuous flow. It goes through a grind, it goes through a passage, it's lifted, it's sifted, goes to another roll, and we keep reducing that product down until there's no endosperm left to become flour.
Now transformed, the wheat journey continues. Bulk trucks will carry 50,000 pounds of flour to their final destination, which could be a bakery near you. After all, where would we be without our morning toast? But with so many different varieties, which wheat bakes into the best loaf of bread?
We use hard wheat for a yeast-based product like bread to give it that strength to allow it to withstand the high temperature and then set as a loaf of bread. In a cracker or a cereal, you don't need that structure.
Bread making is Chemistry 101, using flour and yeast. Mix the two together and the yeast will consume the carbohydrates and sugars within the flour. This process generates energy in the form of carbon dioxide gas. Because of its elasticity, the gluten protein left in the flour traps the gas, causing the dough to rise.
Now keep in mind, this is really exciting because bread in itself, at a point in the operation, it's alive. We actually have yeast that's growing.
Few realize the importance of wheat flour, like industrial bakers. Oro Wheat has been baking bread for almost 80 years. They know that there are few, if any, more iconic symbols of home health and happiness than a loaf of bread. Here, wheat flour is the vital ingredient for the 12 million pounds of baked goods produced each month.
You know, we as bakers, the main ingredient is flour, and everything we do is based on flour.
Americans consume over 100 pounds of wheat flour a year, much of that in the form of bread.
There's about 53 pounds of bread that's consumed by the average American consumer every year. So when we look at that 53 pounds of bread, we want to make sure that we're giving the consumer bread that's healthy and nutritious.
Ever wonder how bread bakers perfect their recipes? They can't taste every loaf, so they test the flour.
This tells us about the quality of the flour, what kind of loaf of bread is going to be produced if we use this flour. It's got a mixing bowl which can mimic what is going to happen in the bakery. It tells us about the mixing tolerance index. How strong is this flour? Is it going to take the stress in the mixer?
So, without strong flour, we'd have weak bread. Sometimes nature has a funny way of working. Salmon have to swim upstream to mate, salamanders can regenerate lost limbs, and wheat will grow just about anywhere with the right prodding. But what could certain fish and amphibians possibly have in common with wheat? Surprising as it sounds, they share a genetic trait. All three are polyploids. The cells of polyploids each have more than 3 sets of chromosomes in common. Wheat, it's actually 6 sets, 3 times more than in most human cells. Because of this, wheat has a survival advantage. It's versatile enough to survive practically anywhere. But how? It's all the result of thousands of years of natural adaptation and a little human intervention. For centuries, wheat farmers not only grew different strains, but studied which had better yields and which didn't succumb to disease. Today, modern geneticists and breeders do the same thing. But why put so much time and energy into wheat? For one simple yet compelling reason: wheat still feeds the world.
If we can create, for example, varieties of wheat that can withstand higher temperatures, then in areas maybe where wheat was not commonly grown, or even if it was grown, the yield was low, but now with the new varieties that are more tolerant to heat stress, these varieties will produce more grain. That is a significant achievement. And that is ultimately our goal.
To move forward, it helps scientists to step backwards and understand where wheat comes from. After all, knowing your family tree can certainly fill in a few blanks, even when your family tree is a grass. Ancient wild wheat, which still grows in the Middle East, only contains a few kernels in the head and falls to the ground when mature, making harvest a back-breaking venture. But about 8,000 years ago, a mutant wheat plant that kept its head of kernels intact must have attracted the attention of an early botanist.
When man came out of Africa, he saw these pure stands of wild wheat growing in the Middle East. So these plants, of course, at maturity, you will be able to see this plant a mile away because the spike, the head will be still there, whereas all the others, the head will be fallen off. So that man was a genius.
Think of genetics as an elaborate game of chance, where a 1 in a million mutant may eventually change an entire species with enough time and a little help. So how different is ancient wheat from today's wheat? A lot different. These days, an average stalk of wheat contains dozens of seeds in the head, unlike its ancient predecessors, the result of thousands of years of nurturing and breeding.
So wheat breeders' job is to develop new varieties that farmers will grow in their fields. Primarily our goals are to improve productivity so that we produce more grain, also to protect that yield potential against pests and diseases and other stresses that the crop will face in the field. We also want to improve the quality so that it makes a good loaf of bread or a good cookie or whatever the end use is for that particular variety of wheat.
Breeders have been in the fields for thousands of years, but today's geneticists lend a helping hand or a microscope from inside a lab. In one ongoing study, geneticists are searching for specific genes in wheat that allow the plant to thrive in high-stress climatic situations. For geneticist Zoran Ristic and his team, the goal is to determine which wheat genes do best at high temperatures. To test these stress tolerances, specific wheat plants are grown under precisely controlled conditions.
We simply harvest all of these plants, collect the grain, and then assess the yield per plant. So we count number of seeds, we measure all the seeds, we determine the mass of individual seeds, and then we can make comparison between plants that were experiencing heat stress versus those that did not experience heat stress, so-called control plants, and compare different varieties of wheat.
Why bother? Because climate change causes crop stress, and crop stress can lower yields, and that worries everyone from growers to geneticists to consumers. Even today, our global food supply is precarious, reliant as it is on nature's soil, water, and oxygen. However, farmers and scientists all over the world strive to make the system stable and devote their lives to this purpose.
My objective is not only to satisfy my curiosity and to study how plants respond to heat stress, but also to try to help our nation and humanity throughout the world to improve the quality of food, to improve the production of food, to have better yield under stressful environmental conditions so that we can feed the population.
Super wheat. It'll grow anywhere, anytime. This is the dream farmers had 8,000 years ago, and it's what drives today's wheat breeders. But how does the genetic information from one wheat plant get into another? Physical crossbreeding is both the most historic and easiest approach. And it's simply one low-tech way to pick the best of the best. Breeders select two plants for their admirable characteristics, such as good kernel size and high protein content. The wheat plant is self-pollinating, containing both male and female reproductive structures. Cut the male anthers and their pollen will not reach the female structures. Pollen from another wheat plant can now be introduced, completing the cross. Over thousands of years, scientists have learned a thing or two about this reproduction process. But wheat still hides its secrets. Wheat breeding is much more complicated than it looks.
There's a lot that we don't know, so we talk about breeding as both art and science. And so the science is knowing the genetics, knowing how traits are inherited, how much the environment influences expression of a trait. It's also art in that the breeder goes out in the field to make selections by visually looking at a plant and saying, I like this one, it has good disease resistance, it's the right maturity. As we go along, we see more of a transition towards science and understanding the genetics better.
The human genome is made up of around 25,000 protein-coding genes. The wheat genome is believed to be 6 times larger.
We have a long ways to go in that regard in terms of understanding all the different genes, how they act and how they interact within the genome to give us the product that we have in the field.
Genetic engineering, or the insertion of genetic information from one wheat plant into another, is doable. But that process is left to laboratory research scientists. But with so many thousands of varieties, can scientists really investigate every type of wheat? Yes, this investigation is ongoing at the Wheat Genetic and Genomic Resources Center Gene Bank at Kansas State University. Here, more than 11,000 different lines of wheat seed from around the world are safely stored and cataloged, including 2,500 wild varieties that have survived for thousands of years. Since wheat still thrives in the wild, it only makes sense that studying its genetic secrets may help battle disease, climate, and pest crises in crops around the world. All of this research is crucial to breeders and geneticists. Why? Because the creation of a new wheat variety can take upwards of 15 years to develop. And for those who succeed, the reward is more than scientific.
This one I'm kind of proud of because this is my first million-acre wheat variety. This is a variety called Overly. We released this in 2003. It was the #1 wheat in Kansas in 2006. It's on about 17% of the acres this year, which would equate to about 1.7 million acres. It's a variety that has some interesting characteristics, a very high-yielding variety. It also has a larger seed, which is important because that helps the milling quality, because you can get a larger amount of flour from a bushel of wheat if the seed is larger. It also has very high quality, going with very good yield, and that's kind of a difficult combination to get because they tend to be negatively correlated.
While scientists work to create super wheat, others strive to change, if not shatter, traditional wheat farming practices. Say goodbye to fuel-sucking combines, toxic pesticides, and harmful fertilizers. How about no soil, no fertilizer, and 65% less water than conventional farming methods? This baby wheat, commonly called wheatgrass, contains 100% of the nutritional value of the plant. Unlike soil-based farming, this wheat contains more protein, more enzymes, vitamin B, zinc, and iron because the root system, seed, and shoot are all edible. It is grown using a farming method called aeroponics, a process developed by entrepreneur Richard Stoner. Working with the National Science Foundation, NASA, and a select group of scientists, Stoner is attempting to rethink how we grow food in order to feed an ever-increasing global population.
Aeroponics is the process of growing plants in air in a nutrient-rich environment. Aeroponics is a soilless process, and the plants are suspended 100% in air, both at the root system and at the leaf surfaces of the plant. And it's suspended in an aeroponic chamber, which then delivers a hydroatomized spray to the plants.
It may not look like a Kansas wheat field, but this greenhouse has similar capabilities.
The aeroponic process can grow wheat just like it can in the field. We can plant this entire tray and grow wheat all the way to harvest, where we harvest the grain from the wheat.
But what's the upside to the aeroponic system? It's not designed to replace traditional agriculture, but supplement the food supply and grow vital plants like wheat in places where crops usually aren't found.
We can grow every day, 365 days a year, inside a climate-controlled warehouse. AgriHouse's goal is to put systems everywhere we can and help reduce the carbon footprint. By increasing the amount of biomass per square foot basis, we can grow in densities that have been unheard of in the last 20 years. And so, in that manner, we can supplement and increase the food supply for cities and metropolitans everywhere.
The global population is estimated to reach over 9 billion by 2050, and there's growing concern about a viable food supply. Maybe this soilless system will alleviate some of that pressure because there is no single answer to the future of the world's food supply. Solving this future food crisis will require new innovation, intensive research, and determined farmers. But as in centuries past, wheat's resilience may well carry us through difficult times.
Cheers.
Cool, refreshing, great tasting. It's beer, quite possibly the oldest alcoholic beverage ever brewed. And wheat plays a part in this ancient science, adding body, taste, and complexity to what would otherwise be barley beer. But what is the element of wheat that provides the unique flavor? It's in the starch.
Wheat beer is an ale, and to compare it to a lager, it's like comparing two different animals. Because a lager is meant to be nice and light and very low color and clean and crisp. A wheat beer is more of a full-bodied beer, and that's what the wheat is doing for us.
Wheat beer is considered a craft brew. Why? Because although it is a key component, wheat is not the main ingredient in the blend. Since 1989, Boulevard Brewing Company has been crafting wheat beer. Cheers. And exploring its tasteful possibilities.
When I taste the wheat here, all I'm looking for is that it's got the proper texture, and I'm really just looking for all flavors at this point. It's nothing analytical right now, but because tasting it and feeling it in your mouth, it's the simplest, most easy quality control check that you can do. Every truckload, we'll get a sample out of the bottom of the truck, and we'll taste it, and we also have a few lab tests that we do to it.
The process of brewing with wheat is no different from that of 100% barley beer, the one everyone knows. Instead, its distinctive taste is formed by chemical reactions at each stage of brewing, beginning with the malt. This is where the brewer tricks the grain into germinating.
Now, the process of malting is where you almost get the grain in an environment where it thinks it's going to become a plant. So what it needs is it needs to feel some water on its feet and some sun on its back, and then it thinks, hey, this is the perfect environment for me to become a plant.
Germination releases critical enzymes that will convert the starch in the wheat grain into sugar. The starch itself is a long chain of sugars. When the starches are broken down by enzymes, they become a form of sugar that another ingredient, yeast, will gorge on. The byproduct of the feast is alcohol. Although this fermentation process resembles traditional brewing, that doesn't mean it's easy. After all, even broken down starch is still starchy.
Wheat is a little bit more trickier than barley to work with. The main difference for wheat is that it doesn't have a husk. So husks on the barley, the main reason why barley is used is because it has this husks that helps as a filtration bed.
Wheat, which really doesn't have a husk, it's just kind of gummy, gets gummy because of all the gums, and so that slows that runoff.
How does a brewer work around these difficulties? The answer is in the recipe. Wheat beer is between 30 and 50% wheat. The rest is traditional barley, the cereal grain that adds clarity, and hops. Hops, a member of the hemp family, lends the brew an acidic flavor, as well as antibacterial properties. But even if brewing wheat beer isn't the easiest, it's the unique flavor that makes it so distinctive for beer lovers worldwide. After all, exploiting the taste of wheat is really what it's all about. And to do so, Boulevard brews against the grain, leaving their wheat beer unfiltered.
Which really means less processing, where you're not filtering all of the ingredients out of the beer. And that's one of the reasons you have the haze, is because you just haven't processed it so much.
And while taste may be paramount, a beer has to look good too.
It looks a little different. It tastes just a hair fuller. It gives a little bit more flavor. It's some citrusy notes in there and some very refreshing notes. And it tastes darn good at the end of the day.
In kegs or in bottles, 70% of Boulevard's business is wheat beer. But it isn't easy to make each batch just as good as, if not better than, the last.
When you buy a six-pack of beer, you want it to be perfect. You want it to be the same, no matter how the harvest of the wheat or the harvest of the hops or the harvest of the barley have been. People want it to be consistent.
Consistency is not only a theme for the brewer, but the wheat breeder, grower, and miller, who all require a combination of science and art to manipulate wheat's unique properties. This multifaceted grain has transformative abilities that are unparalleled. And because of this, there are those who are thinking outside the wheat box. Wheat is the most widely grown food crop in the world. So what if we could use its chemistry to do more than simply feed ourselves? Wheat stores the energy produced by photosynthesis in the form of starch, and every grain contains nearly 60% starch. Starch is a polysaccharide carbohydrate, essentially a long chain of glucose units. It's what causes flour to have the consistency of paste when wet, and as a result, flour is used as a thickening agent. But did you ever think your bread flour could be transformed into plastic? Here at MGP Ingredients Technology and Innovation Center, they have dug into the treasure chest of wheat's chemistry and found opportunity. They call it Terratech resin.
It's probably fair to say that wheat starch has been overlooked a bit. Our objective is to develop bioplastics which will run on existing technology and existing equipment. And that's been a bit of a challenge, but we've made huge progress.
Wheat starch and protein are extracted from flour through a washing process and then dried. The starch is then combined with a secondary polymer ingredient. During an extrusion or shaping process, a chemical reaction occurs, binding these ingredients together. The end result is a biodegradable polymer resin produced in the form of small pellets. These pellets can be molded into products like credit cards, cutlery, and golf tees. But unlike conventional plastic, this wheat plastic is 100% biodegradable. And it's just the tip of the iceberg when it comes to new uses for wheat. What about a new way of looking at food?
Wheat is unique in that it has gliadins and glutenins, and those two components form vital wheat gluten, and that is very unique in the protein world.
Unique because vital wheat gluten, that stuff that holds the grain together, is elastic. It has a consistency like no other protein. It's also tasteless, and it has a texture that surprisingly looks like meat. So, is it a chicken nugget or is it wheat? MGP Ingredients open the door to a new food market that uses textured wheat proteins instead of meat. They call it Wheatex.
Well, Wheatex is very unique in the properties of looking like real meat. So when you take the product and you pull it apart and you look at it, it has myofibrils or strands that look like true whole meat muscle products. And those characteristics directly come from the wheat gluten itself.
This test kitchen is where wheat tastes like sausages, pepperoni, or even crab cakes, since all are made with some percentage of wheat.
The other unique property of being able to use wheat gluten in textured proteins is being able to manipulate the texture of the product.
Who's the customer for fake meat? Meat eaters who want a little less cholesterol in their diet, vegetarians, and manufacturers who want to keep costs manageable. Wheat as meat, or Wheatex, could be the answer. Yet as far as the humble wheat kernel has come, creative and scientific advancement doesn't stop.
We don't know everything there is to know about wheat. We're always innovating, always finding new properties and new applications every day.
And MGP Ingredients isn't the only company exploiting the pliability of wheat's chemistry. Environ Biocomposites has gone where few have ventured, not to the grain, but to the straw. Tough, strong, light, and plentiful, wheat straw has traditionally been treated as a useless byproduct. But now it's the revolutionary ingredient for new building materials.
The fibrous part of this wheat straw, you notice, it's fairly strong. So it does have certain inherent structural properties that other particles would not have. The torsional or longitudinal strength of wheat straw, you can see what I'm doing here, you can actually tug on it pretty well, and that's that strong, solid fiber.
Named biofiber wheat, this sturdy offering is both an aesthetic and functional alternative to traditional hardwood or particle board products.
If you get particle board wet, it swells. But if I get the wheat board wet, it swells only 1/3 as much. So it's going to be much more dense, it's not going to swell as much, and at the end of the day, you have a non-formaldehyde ingredient.
In wood-based particle board, carcinogenic formaldehyde is the binder that keeps it all together. But with biofiber wheat, Environ uses a urethane-based resin that keeps performance high and the customer safe. Wheat straw is trucked into Environ's Minnesota factory from across North America and Canada in bales weighing 1,250 pounds, which also happens to be the average weight of a dairy cow. After inspection for rot and any garbage, the wheat straw enters the first machine on the line where it's gnawed into small fibers.
We blend it with a resin. It's a formaldehyde-free resin that we run through the system. You get a core and a surface. We have something called a 3-layer former that lays down the bottom, the middle, and then the top. So you get 2 surfaces and you get a core.
This layering technique improves durability and strength for cabinets, furniture, or floors, even for wheat doors. But perhaps most intriguingly, Environ's manufacture of biofiber wheat creates a negative carbon footprint according to the U.S. Department of Agriculture. This is just another reason that there's growing interest in wheat beyond its value as food. But in the end, these amber waves of grain in the field connect us to the centuries-old traditions of farming, family, hearth, and home.